Hello everyone. So today we're going to discuss the inventory management and EOQ model. Then we're going to apply what we know through an example relating to the cosmetic retailer Sephora. Okay, so now let's get started. Now I'm sure you're wondering, what is an EOQ anyway? Well, an EOQ, or an economic order quantity, is the order quantity that minimizes total holding costs and ordering costs. This model is most helpful when managers have to make decisions involving inventory management. As managers, we must focus on minimizing three kinds of costs regarding inventory. The first is carrying or holding costs, which involve things like insurance and capital. The second is the ordering costs, which involve logistics in the process itself. And lastly, we have to minimize the shortage costs, which means that we cannot lack inventory that is in high demand. With the EOQ model comes 5 assumptions. The first assumption is that demand is known and is constant over time. The second assumption is that no shortages are allowed, which means that shortage costs should and must be $0. The next assumption is that lead time for receipt of orders is constant, and lead time is the time between an order being placed and the order being received. The next assumption is that order quantity is received all at once. And finally, the last assumption is that costs are always both known and constant. So, when a product is in high demand and shortages in inventory are not an option, what do? And here we have a visual representation of the EOQ model. As you can see, as the inventory level decreases with the demand rate, it will eventually surpass your reorder level, which is the fixed amount where you decide to restock your inventory if it is surpassed. This is especially important to keep track of since, as I previously mentioned, shortage costs must be $0. Hence, inventory can never go below 0. If you look at the lead time, you can see the demand rate rises again immediately after the receipt of an order. And as I said before, the lead time is the time between the order being made and the order being received. Alright, now this is where we start looking at the formulas to actually read our data. As you can see here, CO represents the ordering cost, and CC represents the carrying cost, D represents annual demand, and Q represents the order quantity. To find the annual ordering cost, you have to divide the demand by the order quantity and multiply that by the ordering cost. To find the annual carrying cost, you have to divide order quantity by 2 and multiply that by the carrying cost. And to find the total cost, you just have to multiply the ordering cost by demand and divide that order by the order quantity. Then you add that to the carrying cost multiplied by order quantity divided by 2. And here's a graph representing inventory costs. Now you see where the carrying costs and ordering costs intersect? That's where we're going to find the optimal order quantity, which is how we produce minimal costs. There actually is a formula for that. And it looks like this. Optimal order quantity is equal to the square root of 2 times the ordering cost times demand divided by the carrying cost. Sounds easy enough, right? Well, let's try applying it to the real world, shall we? Our example is going to involve the inventory management for the cosmetic retailer Sephora. Sephora stocks any high-end brand of lip product that you can imagine. Its biggest seller is currently Tarte's Lip Surgeon's lip creams. The product is so successful that the retailer is constantly in need of replenishment of the product supply so that it does not go out of stock. Sephora managers must determine the optimal order size and total inventory cost for the Tarte lip creams given an estimated annual demand of 50,000 tubes of lip product, an annual carrying cost of 50 cents per tube, and an ordering cost of $500 per hour. So what is our optimal order quantity? All we need to do is plug in the numbers for the formula. From looking at this problem, we know that demand is 50,000 tubes, carrying cost is 50 cents per tube, and ordering cost is $500 per order. So you just multiply 2 by 550,000. Then we divide that by 0.5, which is 100 million. and the square root of that is 10,000. So the optimal order quantity would be 10,000 tubes of lip product. Now we need to find the total cost. This is also just a matter of plugging in numbers into a formula. Now that we've found the order quantity, which is 10,000, we can solve this rather easily. Now, remember that in order to find total cost, you just have to multiply the ordering cost by demand and divide that by order quantity. So what we do here is just multiply 500 by 50,000 and divide that by 10,000. Then we add that to 0.5 plus 10,000 divided by 2. Now to know that you're doing it right, you see how both these numbers here are 2,500? Well, that's for a reason. Those two numbers should always be the same. So we just need to add that up, and you'll see that the total cost is $5,000. Now, Sephora also desires to know the number of orders that will be made annually and the time between orders, which is also known as the order cycle. For this example, we will assume that Sephora operates 365 days in a year. To answer this, we're going to need to find the number of orders annually and the order cycle time. To find the annual number of orders, you just have to divide demand by order quantity. So we'll be dividing 10,000 by 50,000, which equals 5. Now, to find the order cycle time, we simply divide the annual number of orders by 365, which comes to 73. So the order cycle is 73 store days. And that's pretty much all you need to know in order to properly manage your inventory through the EOQ model.
And that, my friends, is how you manage your inventory through the EOQ model. And as long as Sephora managers use this model, you'll never have an excuse to not be able to rock this look.